Hello. In today's video, we'll be taking a look at this dynamics problem involving rectilinear motion. In this example, we are given the velocity as a function of time for this particle that starts at the origin at t equals 0. For this problem, we're going to assume that the particle can only move along the x-axis. So this simplifies our analysis significantly. In this problem, we want to find the acceleration at t equals 4, how far the car traveled from t equals 0 to t equals 4, and the average speed from t equals 0 to t equals 4. So to start with part 1, we know that the derivative of velocity with respect to time is going to be acceleration. So if we just take the derivative of velocity equation up here, we'll get the acceleration as a function of time for this particle. So using the power rule, we get that the acceleration as a function of time for this particle is 8t minus 2. Now, we want to find the acceleration value at t equals 4. So all we do is simply plug in 4 for t and evaluate. So 8 times 4 is 32, minus 2 is 30, and the units in this is going to be meters per second squared, since our velocity was meters per second. All right, so that is our answer for part 1. Now let's take a look at part 2. We want to find how far the car traveled from t equals 0 to t equals 4. So now we want to use the fact that our displacement, or we'll call in this example change in x, is going to be equal to the integral of our velocity function with respect to time. So applying this to our problem, our displacement is going to be equal to the integral from 0 to 4 of 4t squared minus 2t plus 1 dt. And this is another simple power rule question, so our antiderivative is going to be 4t cubed over 3 minus t squared plus t, and this is going to be evaluated from 0 to 4. I already went ahead and did this, so our displacement is going to be equal to 73.3 meters. All right, now for our last step, part 3, we want to find the average speed from t equals 0 to t equals 4. The average speed formula is given as the change in x divided by the change in time. So since we know that the particle starts at the origin at t equals 0, we know its final position is just going to be essentially whatever accumulated over those 4 seconds, which we know is this value right here. So we can say for our x2, or we'll call x final, we'll call this 73.3. Our our initial position is just simply going to be 0 because it's at the origin. Our final time is 4 seconds, and our initial time is just going to be 0. So coming over here and doing this equation, we get that our average speed is going to be equal to x final minus x initial over t final minus t initial. So now if we just plug in these values simply like this, we'll get that we have 73.3 minus 0 over 4 minus 0. So now if we go and do this basic division using our calculator, we get that the average speed during this 4-second interval is 18.3 meters per second. So there you go. This was a relatively easy problem to introduce you guys to fundamentals of dynamics involving basic calculus, integrals, derivatives, and how to apply it. So yeah, thank you for watching.